This is the M117, particularly the 5.5 liter version. This one in the picture here has the headers on it, which is almost impossible to find now. Mine has the small crossover tube from the left side to the right side that I am sure restricts power. Here you can see the fuel distributor and the air metering device or airflow measurement device that then controls fuel flow. System uses this Bosch K-jetronic system. This is a very reliable system. This is the Bosch technical instruction. These are very handy. They used K-jetronic injection systems on a number of vehicles, I believe. The Porsches and Audis used it. My car has 218,000 miles on it, and I kind of doubt it's ever been serviced, really. It's starting to give me some trouble starting and under quick throttle responses. Got a lot of hesitation. We just run through this. I won't get into too much detail about how the system works. You can look at this manual for yourself. I'm definitely not an expert on the system. There's the ejector spray path. So basically, this is a continuous flow injection system. Though these nozzles, this pintle valve actually vibrates, buzzes, and helps break up the fuel. These injectors are also shrouded with air, and they're just showing the injection pattern without and with the air shrouding. So unlike a modern fuel injection system where the injectors only open either with the intake valve open or closed, or even the older EFI systems where it would just be untimed injection and just fire a whole bank of injectors at one time in what's known as batch injection or batch fire. This system is just continuously flowing fuel through the nozzles. And how it meters the fuel is with this airflow sensor, which is basically a plate in a very special design kind of venturi here, or funnel. And air enters, and as it travels through here, it moves this plate. In the car, this is actually, I believe, kind of upside down. So the air comes in from the top and pushes the plate down. And the further it depresses the plate, the more fuel that will flow through the injectors, effectively making a mechanical airflow sensor, which in turn regulates the fuel injection flow rate. The K-jetronic, all it does basically is adds a electronic pressure relief valve, and the ECU is able to kind of bleed off some of that fuel or choke the system to increase the fuel pressure, as most pressure regulating devices control the return flow fuel or oil or whatever the system is. And I was just looking if that valve was shown here. This is, so here they call frequency valve variable restrictor. I believe my system might be slightly different, but basically the ECU is mapped a little bit to control the fueling with this pressure relief valve, and it's just shown with the oxygen sensor. It will close the loop and make small adjustments to try to perfect the air-fuel ratio. I'm not even sure if my system is working properly or if it's just running on the mechanical system alone. That's kind of the nice thing about the K-jetronic systems is that if you were to, unplug the ECU basically, it should still run decent on the mechanical system. However, the system is very sensitive and it's very hard to adjust the fuel. Here's a better picture. And this is the fuel distributor, so it looks like they're showing a 4-cylinder system. And there would be hard lines coming out of this distributor going to each of these nozzles. I'm not too interested in trying to restore the mechanical injection system. I'm sure some purists would prefer that, but for me, I'd rather bring the car up into kind of the modern era with electronic fuel injection and have the tunability that affords. The engine's high mileage, so we'll see how long it goes. I plan on keeping the car a long time. If the engine were to fail, it's really not worth to rebuild. From what I've seen, it usually costs around $10,000 to overhaul the engine. And it has some unique things with it. It doesn't have any steel on the cylinder walls. It's a alu-sil block, which is a high silicon content, and it uses a special acid honing procedure. But I digress. I don't want to get too far into that. So as with any project you may have, or whether you're designing something or engineering something, you always want to look at kind of past works, any previous works that people may have done, whether that's patents or just other people on the internet that have done it, um, whatever it may be, just to try to get your feet wet in the subject. So we just do a quick search on a 560 SEL EFI conversion, and most people only do it to the 560s and the 420s because it's the only ones really worthwhile. I think the inline six people do it a lot because they usually end up putting turbochargers on those. Anyhow, a quick search here, we get quite a few results that look promising, so I just clicked on a few of them here. Alright, so looking at previous work here, I wanted to show, first off, we need to have a crank signal, engine position, and speed signal into the ECU so that the computer knows where the engine is in its rotation. Mostly the speed, I'll be using a batch fire injection, so I don't need to know if it's in phase or not, and I'll be using a wasted spark ignition with the micro squirt. So these are real common. The 36 minus 1 trigger pattern, which means it has 36 teeth minus 1 or 60 teeth minus 2. I'm not sure. It looks like you're probably using a 60 minus 2 here. Looks like they're just taking the wheel and basically pressing it over the crank pulley, which is pretty smart. It's nice to know that it has the room already here, and I don't have to remove the harmonic balancer. It looks like that will actually just unbolt off the front. I do see some balance weights, so I'm not sure if this is just zero balance or that's part of the crank balance. I would imagine that's just a zero balance. Something else is you'll need to be able to mount the injectors. Looks like this guy here is planning on using LS coils, this 300 SD81 guy, and this Benz guy has also done the conversion. And he provides a lot of information. I will say this guy Really, really has some good information. Um, he made this 3D print of what the intake manifold basically looks like. If you were to remove the mechanical injector, you'd be left with this large hole. And if we look at the Bosch injection valves, these are the EV14s. I would probably be looking at using the standards or the compacts. And because the length of the mechanical injection nozzles, it's ideal to get this extended nozzle. And what you'd want to do is make this little bushing or spacer. And I believe you just turn this out of a piece of aluminum, and that will go inside the intake manifold where the mechanical injector was. This is kind of what you're left with. Now I may, not sure, sorry, I'm not sure if I'd really want the nozzle protruding into the intake like that. I feel like dirt could maybe collect on there easier. So I'll just look at mine. I may end up having this injector raised up a little bit in the spacer, or I could possibly just go with the standard nozzle and make sure the injector seat's deep enough in here. But that's helpful. It looks like it's kind of what other people are doing. Well, that's the same guy there, but um, making these spacers. And then you can just buy this fuel rail on eBay. It's pretty cheap. You just buy it by the foot basically. And they even make a drill bit that will drill into this fuel rail for the injectors to sit in. And see if one of these guys actually, here you can actually see it looks like he has the factory ignition timing map. Not sure how he found this or if this was out of some kind of manual, but that's very useful to have kind of a base timing map that you could program into the ECU and maybe have a starting point or an idea. Looks like this guy here is using a MS3, which is capable of sequential timed injection. It can help a little bit with low speed and idle, but probably not too noticeable. Looks like he mounted ignition coils just straight across the front of the motor. I think I'd prefer to use the 4 tower packs, and I can show that here, and maybe mount those somewhere else. I think if I went with the individual coils, I would probably try to mount them on the valve cover like the LS engines do. A big advantage of going to individual coils is with the MS3 you can have sequential ignition timing instead of wasted spark, but there's not too much benefit with doing that. And what else can we look at here? Here we go. Here's what that fuel rail extrusion looks like. This stuff's real popular. You can use it anytime you're converting something to EFI. You can just cut it to length, and then they make a drill bit that will actually put this O-ring counter bore as well as pierce all the way through into this passage that's already in the extrusion. And what's nice about the Bosch Motorsports website is that not only do they provide dimensions and part numbers and all the technical specs, flow rates and angles and dead time, is they provide the CAD too. You can actually download the 3D model, and then you can, if you have a modeling program, there's some free ones out there. You can assemble it. This is actually a really good book. This Performance Fuel Injection Systems, written by Matt Kramer and Jerry Hoffman. These are the people behind Megasquirt systems. And originally, I will say the Megasquirts were built by a company, Bowling and Grippo, but I think these guys kind of played the forefront in some firmware upgrades and really just making the systems what they are today. This book is very handy if you plan on putting an aftermarket fuel injection system on something or converting from carburation to fuel injection. It's a great book. Looks like this guy's probably doing some injector flow testing or something. So yeah, I wouldn't say I'm going to directly copy what these people do, but it's always great to look at kind of what people have done in the past. And I think that trigger wheel on that pulley, that's great information. And making these little spacers for the intake is a great option as well.